Ionosphere, Earth's blanket of charged particles. An ion is an atom or molecule with a net electrical charge. For atoms that lose electrons, an overall positive charge will result, more protons than electrons. Atoms that form these types of ions are called cations. While atoms that gain electrons, an overall negative charge will result, more electrons than protons, are called anions. Ionization is the process by which an atom or a molecule acquires a negative or positive charge by gaining or losing electrons. Ionosphere. It is the region where high-energy radiation from the Sun has knocked electrons loose from their parent atoms and molecules. The electrically charged atoms and molecules that are formed are called ions, giving the ionosphere its name and endowing this region with some special properties like reflecting radio waves allowing radio communications. The ionosphere is a dynamic region of Earth's atmosphere that spans the mesosphere, thermosphere, and exosphere. It is not a distinct layer and actually grows and shrinks depending on how much energy it is absorbing from the Sun. The ionosphere is located from 60 to 300 kilometers above the Earth's surface. It is divided into three regions or layers: the F layer, E layer, and D layer. During the daytime, the ionosphere consists of four layers: D, E, F1, F2. At night, the D layer essentially disappears while F1 and F2 layers recombine to form one layer, F. The D layer is the lowest region of the ionosphere, situated approximately 50 to 90 kilometers above the Earth's surface. Unlike the higher layers of the ionosphere, the D layer contains a lower density of free electrons, as ionization primarily occurs due to the absorption of solar radiation. This layer is most prominent during the daytime, diminishing significantly at night when ionizing radiation from the Sun is absent. The D layer can absorb high-frequency radio waves, leading to signal attenuation and degradation of radio communication, particularly for frequencies below 10 MHz. Its presence and behavior are also influenced by solar activity, such as solar flares, which can temporarily increase ionization levels and affect communication signals. The E layer. The E layer, or the electrical layer, lies approximately 90 to 150 kilometers above the Earth's surface. This layer is mainly ionized by the soft X-rays and also by EUV, extreme ultraviolet. It's a thin layer, roughly 5 to 10 kilometers thick. During daytime hours, the ionization characteristics are practically similar to those of the D region. The E region can be regarded as the transition zone from the Earth's atmosphere into space. There are discontinuities in pressure, temperature, and chemical composition at this height. The F layer. The F layer is ionized by extreme ultraviolet light, EUV, and high ultraviolet. During daylight, it splits the layer into two parts. The lower part starts at roughly about 150 kilometers altitude and becomes the F1 layer. The higher portion begins at about 200 kilometers altitude and becomes the F2 layer. The given heights are not to be taken as absolute, they vary continuously. The F1 layer is much weaker and plays only a minor role in propagation. It acts more like the E layer than the F2 region. One important layer from the standpoint of navigation and communication is the F2 layer, where electron concentrations reach their highest values. Electron density. D region, E region, F region. Processes in the ionosphere also create bright swaths of color in the sky, known as airglow. UV airglow. Red line airglow. Green line airglow. Airglow occurs when atoms and molecules in the upper atmosphere, excited by sunlight, emit light to shed their excess energy. Or, it can happen when atoms and molecules that have been ionized by sunlight collide with and capture a free electron. Airglow as seen in this video of Earth's limb, shot from the ISS. Skywave propagation is the behavior of radio waves when they are transmitted through, or reflected from, the ionosphere back to Earth's surface. Transmissions from radio stations can bounce between the Earth's surface and the ionosphere many times. As the radio signal is transmitted, some of the signal will escape the Earth through the ionosphere, green arrow. The ground wave, purple arrow, is the direct signal we hear on a normal basis. This wave weakens quickly and is what one hears as a fading signal. The remaining waves, red and blue arrows, are called skywaves. These waves bounce off the ionosphere and can bounce for many thousands of miles depending upon the atmospheric conditions. The ionosphere is a region of Earth's atmosphere that is ionized by solar radiation. It serves several important functions. 1. Radio signal reflection. The ionosphere can reflect radio waves back to the Earth's surface, allowing for long-distance radio communication. This is particularly useful for high-frequency, HF, radio transmissions. 2. Satellite communication. The ionosphere affects the propagation of radio signals to and from satellites, which is important for satellite-based communication and navigation systems. 3. Atmospheric shielding. The ionosphere helps shield the lower atmosphere and surface from harmful solar radiation, particularly high-energy particles and ultraviolet radiation. 4. Atmospheric dynamics. The ionosphere interacts with the Earth's magnetic field and influences atmospheric circulation patterns, which can impact weather and climate. 5. Aurora formation. The ionosphere is responsible for the formation of auroras, the colorful displays in the night sky caused by the interaction between solar particles and the Earth's magnetic field. Overall, the ionosphere plays a crucial role in facilitating long-distance communication, protecting life on Earth, and influencing atmospheric and space weather processes.